Okay, so now we're moving on to 6.2, parallelograms. Be careful of the spelling, not that it would be too much of a problem if you spelt it incorrectly in an exam, but try and remember how to get the spellings correctly as best as you can. Okay, so here's the table of all the theorems, 6.3 to 6.6. Okay, so these are all the properties of parallelograms. Opposite sides for 6.3, opposite sides are congruent, opposite angles are congruent. So taking that one and going into 6.5, if they use letters instead of the notation, the angle notation, so just be careful of that. Okay, and if a 6.6, if an angle has one right angle, then all four are. So the parallelogram, even though technically once it's got four right angles, it should be either a square or a rectangle, be very careful, because sometimes the examiners are crafty. They will leave it in as a parallelogram. You think it's a rectangle or a square, and it sort of takes you off track a little bit. So be very careful questions like that. Okay, so here's proof of theorem 6.4. Write a two-column proof. Okay, it's again usual one. It's given statement. Okay, and then working through it. Definition of a parallelogram is that opposite sides must be parallel. Angles must be supplementary, because don't forget, G and H must be 180 degrees, H and J 180 degrees, etc., etc. So they're all supplementary. Okay, and then opposite angles must be congruent. So here's example 1. Question A, let's have a look at A. Angle NMQ. So NMQ is this guy. So this angle here must be 32 degrees. And then it's asking you for MNP. So we are then looking at this angle here. Okay, well, let's work out what you do know. You know the 32 plus angle, and we're going to call it angle N, must equal 180 degrees, because don't forget they're supplementary. So angle N must equal the 180 degrees, subtract the 32, which is going to give you 148 degrees. Okay. And here's the one that's going to give you your algebra. Okay, again, be very careful. Make sure you look at each of the diagrams. So for instance, if I look at TP, that gives you 2y minus 5, and then y plus 4. They must equal each other. Substitute in and solve, and again work out what it's asking you for. Is it finding the value of, in this case, the value of the indicated variable, which in this case would be or whatever y is worth, or it's plug it back in and solving. Okay, so be careful. They've given you an easy one. They've given you the 5x, which is this side here, must equal this guy. So obviously 27 divided by 5 will give you 5.4. All right, here's question number 2. Again, look for what you do know. Opposite angles must be congruent. So 2x minus 1 must equal 75 degrees. Add 1 to both sides, so 2x must equal 76 degrees. And then you're going to divide through by 2, which is going to give you 38 degrees. Okay, typical type of exam type question. Parallelograms, don't forget the diagonals of a parallelogram must be congruent. So therefore the midpoint of both the two diagonals must meet at the same point. They must have the same coordinates. Okay, and then obviously, as you can see from example 3, what they're doing is the midpoint twice. And if you get the same point, which in this case we have, which is 0 and up a half, then you know that they are, the midpoints are the same from both diagonals. It is a parallelogram. Okay, so here's question number 6 we're going to look at. Determine the coordinates of the intersection. Very quickly, just draw it if you need to. You know me, I'm a visual person. A, B, C and D. and find the midpoints of AC, and then find the midpoints of BD, and if they're the same, then you've got them intersecting. Well, let's have a look at AC, and you know that the formula is to add the two x's together, divide by 2, the y's divided by 2. So we've got negative 4 plus 4 over 2. There's your x coordinate, and your y coordinate would be 6 plus negative 2 divided by 2, which would give you 0 and 2. Okay, then you need to do BD. Same thing, but different coordinates. This time it will be negative 5 plus 5 divided by 2. There's your x coordinate. And negative 2 plus 6 divided by 2 is your y. Well, negative 5 add 5 is 0, so we've still got that bit. That's okay. Negative 2 add 6 is positive 4. Positive 4 divided by 2 will give you the coordinate. And as you can see, both of these are the same. So you've proved that. Okay, and here's example 4. Again, it's writing proofs. I know you guys are a little bit fed up of writing proofs now, but keep it simple. All right, if you have a look at what they've got, first of all, what you're given. Okay, since opposite angles of a parallelogram are congruent, so you can work out the angles. Okay, you're also told that as well by the given. You can work it out by the fact that it's an isosceles triangle, so these two angles equal each other, and so by the transitive property of congruence you can prove that. Okay, writing proofs, I know you're fed up of it, but just take your time. Go with what you're given. What have you got to find? Fill in the gap. Okay, so question 7, again, writing a proof. Start with what you're given. All right, it's the big one, so everything tells you here that it's a parallelogram by the diagram, and angle A is a right angle, and that's given in the diagram also. Okay, by 6.6, if angle A is a right angle, then B, C and D must also be right angles, but that's the bit you've got to prove. So let's work through that. So look at what we can do. If this is if angle A is a right angle, then AB must be, first of all, it must be congruent to CD, and AC must be congruent to BD if it's a right angle. But what else can we turn around and say? Well, AB must be perpendicular to AC. Similarly, all the way around you can do the same thing. Okay, the last theory which we can use is, don't forget, opposite angles must be supplementary. So if angle A is 90 degrees, then obviously angle D must also be 90 degrees, which means that that is a right angle. You've proved that. Okay, and what else can you prove? Well, if everything's perpendicular, you can just turn around and say that angle C is congruent to angle B. Again, both of them are 90 degrees, so they're both right angles, and there's your proof by the right angle theorem.